we can complete this chart by resolving all the given here in the series circuit, no, for this example. But first, let's try to identify all the given. So for this, we already know what is R1. R1 is given as 2 ohms. Okay. Our R2 given as 1.5 ohms. R3 is 2 ohms. Okay. Now we need to find the total resistance or the equivalent resistance. For series circuit, you need to add all the individual components, no? Meaning you have to add all these resistors 1, 2, and 3 to get the equivalent resistance or the total resistance. So to get that, we will have R sub T, R1 plus R2 plus R3, and then substitute the value. We will have 2 ohms plus 1.5 ohms plus 2 ohms, so that will give us 5.5 ohms, right? So if this is our RT, we can now write it down here in our chart. So that is 5.5 ohms. Okay, since we know what the voltage is, which is this one, okay, so we can write it as 6 volt here in the chart. Now we already have the value for the total voltage and the value for the total resistance. We can now find the total current in this series circuit. Okay, to find it, you have to use the formula I sub t is equals to V sub t over by R sub t. And then, putting in the value for V sub t, we have 6 volts, all over by the computed value for RT, so that is 5.5 ohms. Okay, and down, that's going to be 1.09 ampere. Now, in a series circuit, the rule for flow of current is the total amount of current is also the same as the individual current flowing in each of the component. So that means that the total current is also equals to I sub 1, also equals to I sub 2, also equals to I sub 3. Okay, so now we can plug in the value for the computed value, which is 1.09 ampere. They're all the same, 1.09 ampere, 1.09 ampere, 1.09 ampere. Now, for the voltage, the individual voltages in each of the component, okay, is divided, meaning the total voltages is divided by each of the component. So, ibig sabihin, when we add up all the individual voltages, we will have the total voltages. So that is V sub t is equals to V sub 1 plus V sub 2 plus V sub 3. Right? Now, before we get into this, we need to compute first the individual voltages here in the series circuit. So for V1, that will be V sub 1 is equals to I sub 1 R sub 1. So our I sub 1 is 1.09 ampere, okay, multiplied by our R sub 1, which is 2 or 2 ohms. So right, so 2.18 volts. So for V sub 2, so that will be I sub 2 multiplied by R sub 2. So again, our current is the same throughout the entire circuit. Okay, meaning the IT is just the same or similar with I1, I2, and I3. So the value or the computed value for that is 1.09 ampere multiplied by our R2. This is our R2, which is 1.5 ohms. Okay, 634 volts. Okay, now for our V sub 3, you can get it also by using the same formula VIR. So, but we have to use the subscript, no, assigned for the voltage, current, and resistance, or resistor rather. So for V3, we have I sub 3 multiplied by R sub 3. So our current is still the same, 1.09 ampere right? Multiplied by R3. R3 is 2 ohms. So that is going to be 2.18 volts. Now, if we add all this together, okay, yung V1 and V2 and V3, we should come up with 6 volts or near 6 volts at least, right? So let's plug in first the 2.18 or the V1, V2, and V3 here in our chart. So we have 2.18 for V2 is 1.634 or 1.63, and then for V3 is 2.18 volts. Now let's try to see by adding all these three if they will sum up to 6 volts. So we have 2.18 plus 1.63 plus 2.18, that will give us 5.99, okay, or just simply 6 volts. Alright, so that is how you solve for the individual voltages, individual currents, and of course solving for the total resistance.